There you go. So we're recording, and what I'm gonna do is I'm gonna do a quick overview again of the platforms. I don't think it's necessary at this point because you have seen pretty much everything, but just in case. Again, this is the platform that is counting your attendance. That's why we don't share the Zoom link directly, and it's also going to track the individual assignments you guys are going to submit. These individual assignments are living in our own platform. This is the one that I'm ready to complete. This one has a quick overview of the course plus a few things from Learn. I have uploaded it to YouTube, but I haven't posted it here. And again, this platform has all the classes. It has the slides for today, and after today's session, the recording will be available here. We will upload it to YouTube. YouTube is pretty much available in any platform, so it's going to be easy for you guys to access it. And here, the Learn platform has the individual assignments to work with. Here's like we have this methodology also for our other courses, and the idea is that you need to combine a few things in order to have a good learning process, right? You will have these classes where we're gonna like the first part, we're gonna introduce topics. You guys will be able to ask questions, etc. But at some point, you have to sit on your own and practice these things, individually, because everyone has a different learning process. Everybody has a different thought process. Lauren, guys, let's do something. This is the first time we do this, so there will be a lot of things to figure it out. First thing, Lauren, if you can't stay for the full lesson, you can watch the recording later. And don't worry, the projects will be available all the time. If you guys have questions, please ask them on the Q&A session. And Martin here, or Colin, or Alex will be able to help me out. If you guys see a question, just stop me. And that is it. So I don't remember what I was saying, but what was I saying? Anyway, the Learn platform here, you guys will be able to complete assignments, right? And you will see a few videos and readings we have, etc. Oh, by the way, yeah, I remember the education process. So you guys have to hammer really hard on individual things on your own. The analogy that we say is that when you guys are faced with building a system, I don't know what's your experience, maybe you know about something already. Some customer, someone will say something like, hey, I need to build this thing, and if we compare that to something we can touch and see, something from everyday's lives, it's going to be something like, I want to build a car, that's what the customer is asking. Or sorry, the customer isn't even asking about, I want to build a car. The customer is saying, I need to move fast, but cheap, etc., etc., etc. It's giving you a lot of requirements. And facing that problem is hard, not because you will have to interact with the customer and all that, but in terms of programming, it will require you to be really, really, really good with tools, right? So for example, how to use a hammer, how to use a screwdriver, how to use, I don't know, a chainsaw. I don't know how you're going to use a chainsaw for a car, but anyway, you will use individual tools. We have also these tools in programming, right? Like, for example, the first week is all about strings, control flow, if statements, and all that. And the idea here is we want you to put a lot of effort in the individual tool. We want you to do an assignment with a screwdriver 1,000 times, so you're really good at working with screwdrivers. So then the requirement will come, the real life requirement is going to say, hey, you need to build a car, and how to use a screwdriver will not be an issue, right? So we have to follow this process of mastering the tool individually, and then you will be able to talk about design, to balance different decisions on your programs, etc. So that's why we have so many individual assignments that you guys will be seeing as we make progress in each one of the units. They will be unlocked every next unit. So I have a couple of questions here. So, all right, Martin, you can let me know if there is anything I should respond early. In any case, I will keep just with the class. So let's get started. I don't remember, I think we have more people when we started. You can stop me at any moment. You can ask any question, all right? If you guys have a question, you want to speak it out, let me know. We will promote you to a panelist as Colin, Alex, and Martin, and you will be able to just to talk to us directly. That's the idea of this course. So let's get started. This course is oriented or intended at least for people that are like getting started with programming. So we're gonna see a lot of basic topics. I know that most of you will already know these things, but it's important to at least the first class go to a base, you know, to have a minimum set of requirements before we get started. All right, so I see a question. So let's, guys, we don't want to sell anything right here. We want to just get like ready with the class. We can then help you out with our own courses. Like we can tell you all that later. Not that I don't want to answer. I just want to be like respectful for everyone. If you're here for a Python class, I will not sell anybody anything. So we'll just like, please, like more Python/class topics. And if you're interested in any course from our class, you can just go and ping us directly. We're more than happy to set up a meeting or something and explain to you. So moving forward, first class, Python, right? You guys want to learn Python because of something. You want to build something. You want to either, I don't know, Python is a great programming language because it has so many applications. You know, I think it's the programming language that has more applications out there, along with probably C++. You know, it's like JavaScript is pretty cool, Ruby is pretty cool. All the languages that we know are cool because if we know them, is that they are popular enough to have thousands of people. So you will like hear these battles of Ruby versus Python versus JavaScript. All of them are good at some point. The really good advantage of Python is that it's easy to get started with, has a ton of libraries. To be honest, like everything is partially done. It saves a lot of work, has a great community, and it imposes good practices. So Python, for example, has a styling guide that it's really respected. Like every Python programmer will respect this style guide that we're going to talk about this later. And I don't know, I haven't seen that in any other programming language, you know, and that speaks about the like how important good design, good code, good readability is for Python. And finally, a big advantage of Python is how many applications you have. You know, it's like with the same programming language, you can, let's say you want to do data science, so you're working with your data, you're processing data, you're building like you're building either like analysis intensive applications doing a lot of math to big processing applications using, I don't know, Apache Spark, you know, processing terabytes of data. And then you can like say, hey, I need to publish my results somehow. And then you can go with the same language, you know, with what you already know, you can go on and build a website, you know, in a couple of hours. It's like as simple as that. And you can then go and use, I don't know, Kiwi to create applications. You can create desktop applications, mobile applications. You can do data science. You can do web development. Maybe you find a better language for something like, well, if you want to do web development, maybe today it's better to go with JavaScript. I don't know. That's an opinion, but the true thing is that with Python, you can do pretty much everything. That's a great thing because you know how to switch around. You don't already know the language. You already know the libraries. You already know the bad things about the language, so you can avoid them. You have the tools. So being on the same programming language is great. And without even start to talk about job market, you know, it's like, I mean, you want to increase your salary or something, and I don't know, you can go and do web development for a couple of months or data science as long as you like it and you can do it. It's like you have more options, and that's a great thing. So stop about talking about the language. We don't usually talk about these things during our courses because it's available out there. You know, we want to talk about more important things. Something really important here is that we will try to focus on concepts as much as possible. So hopefully after you finish this class or any of our classes, you will be able to transfer those concepts to any other programming language. That's our idea, you know. Python is a great programming language to get started with programming, but the same concept will be able to apply to either Ruby, JavaScript, Go, whatever programming language you guys want. So, life fact, this is the most important thing. Computers know only about bytes, all right? And this is the most important thing. You know, it's like we do Python, right? We're abstracted. We are working with a high-level language. We write human words, like if this thing happens, while that thing, for this, in that, class, object. This is high-level language. The computer knows about bytes and only about bytes. And it's important to keep that in mind because the issues we're going to have are usually related to that because we forget that after all, we're dealing with to be honest, a really dumb machine. For Python, Python only know about bytes. It doesn't know that if we misspell something, it's going to fail, you know, and computers are considerably dumb in those cases. So what Python is going to do is going to take our high-level language. Of course, Python, what it is, it's a utility for us as human beings to interface with the computer, you know, in a better way than just writing ones and zeros. We could very much go and write ones and zeros. You know, old school computing was done, or programming was done with ones and zeros. You know, like punching cards, ones and zeros to interact with the computer. That is, of course, not scalable today. So we have a high-level programming language, it's Python. So we're going to write our code in Python. We will have the actual Python compiler, right? I'm going to say compiler, that it's a little bit more complex, but Python will take care of translating that to computer code. And this is fundamental. You guys are writing on a high-level language that at some point will be translated back to bytes. So we have here an example. Think about any example, but a really good example is if you're writing a website, you're hired to work on Amazon. You know, you're the first employee on Amazon. You have to implement the Amazon website today using Python. You will be writing the checkout process, right? You will be receiving the credit card from your customer. You will store maybe something in your database. You will submit the credit card details to the payment processor. And when you submit those details, you know, you have captured the data from your customer, you're sending that to your payment processor, and you will be sending ones and zeros. You will write something like send data in Python, but at some point that will turn to bytes, and over the network, it's gonna travel as just ones and zeros, you know, and that's really, really important. You guys are, I don't know, building Spotify, so you will read songs or from somewhere, and those are going to be ones and zeros. You are going to display to your user an image, text or something, but it's going to be ones and zeros. Someone has a question? All right. Remember, guys, we have a Q&A section right there. So if you have a question, just let us know. Like, just post it there. And if you want to show it as panelists, that's also fine. So you can interact with us. So talking about Python, we'll be using today a combination, or in the class, combination of different tools. So one of the things we have learned in our course is that it's really easy to get demoralized with tooling. You know, getting all the setup done is hard. So we try not to put any effort on that. We want you guys to don't waste time with tools right now. When you get a little bit more, I don't know, you gain more expertise with Python in general and the tools we will be using, then you can try setting it up on your own. Of course, we can't like ban you. You can very much go and just do it on your own if you want. It's totally fine. It's actually something we recommend, as long as you're not wasting valuable time of learning concepts, you know. So we'll be using a combination of Cloud9, which is an online IDE, and REPL that just lets you execute code. Like right here, I can execute this code. So let's gonna talk about Python a little bit more. Python is this programming language that you guys are already here. We're having a couple of things here we're gonna analyze in detail, like variable assignments, data types, input and output. We have many things going on in this tiny script. But this is what I was referring when I said you guys will be writing high-level code. You you're writing human readable and speakable, because I can read these to you, language. And this is gonna translate, and Python is gonna translate these to machine code to do something, the final result that you want to achieve. Python will analyze scripts. That's what we're gonna call like these single file programs. We're gonna just call them scripts for short. It's gonna analyze these scripts from top to bottom. So that is really important. As you guys will be defining things and using things below, it's really important to remember that you will be using these, as a step-by-step process. And that means that, for example, let's say I'm going to introduce two bugs. I'm going to do something here. This is going to break it. It's actually Rebel telling me that, but I'm also going to put a bug there. So now when I run this, the line that fails, actually, this doesn't look clear, this one. The line that fails, is this one, because it's not finding, it's actually this one, but it's not finding these closing parentheses. So this is important. This hasn't been evaluated. It's top to bottom. That's how it works. All right, so let's see in more detail what's going on with these type of scripts. And again, remember, you can stop me at any moment, just Q&A or join as panelists if you guys wish. So what is these? These are just a set of steps, right? We're telling the computer what to do, and that's an algorithm. An algorithm is just that. It's a list of instructions or commands. We're commanding the computer to do something in a human readable way. It's like, do these, then do that, define these, go check that to the database, check if the database happened to have a user with this username, please send them a registration email. If the user doesn't exist, please, I don't know, you're commanding the computer on what to do. And we have to be really precise on that, because again, computers are pretty dumb. We have to instruct them, have to specifically tell them everything that they need to do. I remember back when I was studying computer science, like 10 years ago, we had a teacher that made us write algorithms in paper, and the idea was to instruct a robot to do, I don't know what it was, scrambled eggs or something like that. So you had to write your algorithm, to make your robot go and make a scrambled egg. And what used to happen is that, I don't know, you were writing something like, I don't know, Bob the robot, go to the fridge and get an egg. And the teacher could break your algorithm all the time. It's like the robot doesn't know what a fridge is. You have to instruct it, and then you would fix it. Go to the coordinate 3, 5 and open the fridge. And the teacher's gonna say again, the robot doesn't know how to open a fridge. And you would say, okay, go to the coordinate 3, 5. There is a handle. Take it, pull it. That's gonna open a door, and now get an egg. And he'll say something like he doesn't know what an egg is. And this is what happens with computer. We have to be really precise on what we want. Get this thing, multiply by that, store it here. Computer today, it's like we're in the beginning of time. It's everything has to be explicitly told to the computer. So again, sorry, I'm ranting. Algorithms. A list of instructions to the computer, as simple as that. A recipe, go and do that. And you can start thinking about these, and actually I encourage you to start thinking about these. When you guys are, from now on, when you are interacting with a computer, or sorry, not a computer, you're all the time interacting with algorithms. You go and, I don't know, check if you're, I don't know, playing a game, and start thinking, what's the algorithm behind these? Like, I took this decision on the game. What happened? The computer's making a decision. What's the algorithm behind these decisions that I'm making? So that's really important. We're going to express algorithms in this way. It is usually known as a flow chart. Back in the day, I don't know what's the name they give it today, but it was basically a flow chart. It was representing this code in a set of graphics interactions. So here we're saying that the target number that the user should, oh, by the way, let me run this really quickly. This is a guess number algorithm script. So here, this is the final result, the answer. Of course, I shouldn't be able to see it. But if I, for example, if I guess correctly, I'm going to put an A. It says that I won. But if I, of course, miss it, put a 5, it says that I have lost. So this same algorithm expressed in a flowchart is this, right? And we're not going to do flowcharts. I hate them. I'm just trying to show you what an algorithm is and what things we're going to have in an algorithm. So what we have here is we're defining a variable. We're going to speak about, like, we're going to talk in detail about all these things.
I just wanted to ask something real quick.
Yeah.
Where do you actually ask a question in QA? Because you've got the open and answered fields, but I don't see anything where you can like start typing something. Or maybe I'm blind.
Good question. Someone that has created a question knows how to do it. Can someone ask something on the Q&A section? There you go. We have 2 more. Top left of video, Giancarlo. Thank you. Thank you, guys. This question. Good. Thanks. So I'm gonna just put answer live. Done.
Cool.
So yeah, thanks for bringing this thing up. We will have new people, all sessions, but top left corner, you guys can ask questions, Q&A. By the way, if someone wants to join as a panelist, so you guys can speak and ask as Alex did, or Colin. Alex, right?
Yeah.
Yeah. You can just talk, let us know. If you want to join as a panelist, let us know. All right, so moving forward, algorithm. So really simple. This is a flow chart. We're saying a few things. We're expressing the same code as here, but with the flow chart. And the important part here is, aside from the code, aside from this particular algorithm, the different things we are saying. So for example, these looks more like a statement. We're saying to the computer, do something, set this thing to 8, or this is my target number. And then we're asking the user for something. That is more like input output. It's like you're asking the user for something, the user is answering to you. We're then keeping track of that. We're storing data. We're keeping track of data. We're then making a decision, right? If the guess number, oh, by the way, this should be guess. Well, if the guess number is equals to the target, then the user won. And here you have another type of interaction. It's also input output, but in this case, it's output. You're telling the user you win, sorry. And of course, if the answer is no, you're saying you lose. But anyway, we see different things, different ways to interact with the computer, either by telling something directly, like set this thing to something, interacting with the user, asking for input, storing data, from the user. So we're storing data somewhere. We're making decisions. When they were reacting on those decisions, we can then do output. And you can combine any sort of operation or algorithm, recipe, instruction in these 2-3 ways of interacting. So there are actually 3 really important things to do with an algorithm. Either statements, it's a general term, it expresses instructions, statements, expressions. Sometimes they have all different meanings, but just to be clear, like tell the computer to do something, store this, send an email, check that, you're telling the computer to do something. That's a statement. A conditional, like take a decision. If this thing happens, then do that. And finally, loops. We'll not talk about loops today, but they are also a really important feature of any algorithm. And with these 3 things, in general terms, every system out there is built. Like these 3 things are the base of every computer system, from this single script to Facebook to Amazon. Everything is built with this set of primitives, as simple as that. Wait, we have a few questions. Why is your test failing my code? What, Elaine? Right now, my hand. Would you say this is a good way to practice algorithmic thinking? Timothy, I'm answering live here. I don't know. It was a fun exercise. We have a lot of time in our hands. You know, we were young and we were in school. I don't know. We didn't have like access to computers. I'm from Argentina, by the way. We are always 20 years um, behind. So like 20 years behind in Argentina, 10 years ago, it was really hard to get our hands in a computer. We barely had internet, so I think that's why they would do it. Today, to be honest, with how simple it is to write Python and get something truly done, I couldn't say it's a good thing to write things in paper. I mean, if you want to do it, but don't waste your time with that. There are plenty of resources to get something real working. My opinion, I mean, you're free to if it works for you, just go ahead and do it. And Alan, I didn't get your question. Why is you test failing my code? Can you rephrase it, please? Just gonna mark it as answer so I don't have it there hanging. All right, so really quickly, statements. We said these three things, right? Like general primitives will make us, will allow us to build anything. Statements. These are probably the most general ones. Again, there are different ways to name them, and actually we could say that a conditional is a statement, but just to put it simple, we're instructing the computer to do something that we know. It's like create this variable, like assign 3 to this variable, or assign this string to this message, or to this variable, or print that, or send this email on, or whatever. You're instructing the computer to do something that you know. Now, the other thing is a conditional. So you're here making a decision. You're branching. That's what you usually say. And this is a really good example. I took it from Head First Programming. You're branching your code. It's like you're reaching a point when you have to make a decision. The compiler, the computer has to make a decision, you know? And this, of course, this decision will change all the time. Like, I don't know, the user will guess a number. So every user out there running the code will make different decisions, and the computer will have to branch depending on those decisions. Have you ever played to these games like Mass Effect, or what are the other ones? Halo, which like one that has like 1,000 different endings? You know, depending on the decisions you're making throughout the game, the computer is like completely branching, and they have like thousands of different Fallout. There you go, or Skyrim. Yeah, thank you very much. Silent Hill 2. Oh man, that's really common now. I thought Fallout. That's the one that I was referring to, but seems like there are quite a few. So again, the computer is making so many different decisions, you know, and of course that depends on each user. It's not like this decision is going to be hardly imposed, and it's going to be like all the time it's going to be taking the same decision. Depending on what the user is doing, we will take a decision, or what the user is doing, what is happening. Like, you're running a script that doesn't have any interaction with the user. You're running a script every half an hour, checking if, I don't know, it's raining, for example. So you're not interacting with a user, you're interacting with something else, with the environment. You're making a decision based on that. So again, statements, really important. Conditionals, really important too, you know. And finally, loops. We're on purpose leaving them behind, because when we are touch on loops on next class, we're gonna go full with loops. Like, we're gonna show you while loops, for loops, collections. So it's a more interesting thing. For now, we want you guys to focus on things that don't repeat. I think you already know what a loop is, but basically it's gonna repeat. But you guys will be doing here. You will be like digging deeper in these topics. You know, probably most of you already know loops, and you say like, well, what a waste of course I have to wait an entire week to do the loop part. Well, we will hammer you with statements and conditions and all these really, really hard. So it's an important thing to do. All right, really quickly, I don't know if anyone has a question. Remember, Q&A, you can ask any question you guys have. And if you want to join as a panelist so you can interact with us, it's also available. By the way, I'm not paying much attention to the chat. Alex, Colin, Marty, you guys can help me out here. Python features. Let's talk about a couple of interesting Python features. So I'm going to open a REPL. Usually these slides will have a REPL. You guys can access it saved. I usually use Python 3 for this. In the learn platform here, you have a video talking about different Python versions or the difference between different Python versions. So I will not touch on that. So a couple of things that are happening in this script, and again, we're gonna see a bunch of things, and then we will be zooming in each one of these things. So the first thing here, a comment. You guys will be able to write comments in your code, and of course this is silly, but it's an important feature, right? You will be commenting and creating comments in your code. It will also let you, while you are working on something, to try it out. Like I'm not sure if this line should work. I will just comment it out. I will run it, and then I will put it back. Something like that. We usually also use like there are no multi-comments in Python. Something like in JavaScript or Java, you can do something like this. In Python, you can't do that. If you want to build a multi-comment, what we usually do, it's not a comment. It's that we surround things in a huge string, a multi-line string. So with 3 quotes, you get a multi-line string, and that will simulate a comment. This code will not be executed. It will be persisted in the code. So this is an important difference. All right, so we have a comment here. We have a couple of things here. We have this operation happening, like a mathematical operation, and then we're comparing these two with the result of this mathematical operation. This is altogether also a Boolean operation, sorry. So in the same line, actually, I should put here, we have 2 operations happening. This math one, and then when you have the result, this math combined with this Boolean one. Something interesting too in Python, when you guys will be creating blocks, right? Like you will, in this case, an if statement. We're gonna see more detail in if statement. It's really hard to talk about indentation and blocks without introducing anything else. So I'm just going back and forth here. An if statement, right? The conditional part. You will express your if statement, and you will put as the body of the if statement, you will express what you want it to happen if this condition is true. The way for you to write that is to put it in the body of the if statement, and the body of the if statement is this block, right? This block of code that is indented 4 spaces to the right. So all these, as long as I keep putting, I'm trying to put any text here. As long as I'm putting text here, this is all part of the if statement. Everything indented 4 spaces to the right, right? That's the important part. Couple interesting things. Python has a standard library. This is really important. Python has a standard library, and then it has a huge user library, things you can install that someone else did. So think about those of you here that are trying to do web development, think about Django. Django is a user-created library. There are thousands of users working on that, actually, but it's not part of Python. Someone else wrote it, so we can use it, and we can have a website running really quickly. Think about Pandas, NumPy. Those libraries are also user-created. And there is less integration function sections. So is a call equivalent to semicolon as I use in other languages like Java? Montoya, I don't know how to pronounce it. Good question, really good question, because I actually was kind of forgetting. We're gonna talk about, by the way, guys, don't put these are not questions. Colons, yes, thank you very much, because we're gonna actually talk about it when we talk, sorry, I'm gonna show it when we talk about ifs. But really quickly, usually in Python, a colon will create a new block. So answering to your question directly, it is not the same thing as an if, as a colon, as a semicolon sign. This is a semicolon. It's valid in Python, by the way. This works. It's valid. We don't use it though. So don't put semicolons, because if you're applying for a job and you put a semicolon for a Python position, you will probably be shown the exit pretty quickly. Colon in this case is created is put to show where the block is beginning. So when I was talking about blocks, Thank you. This is a really valid comment. The colon will set the beginning of the block. The finish of the indentation, like we don't have any more indentation here, it's going to mark the beginning, the end of the block. So here, this is our if statement block. Of course, it's not valid Python code, but from the semicolon to the end of the indentation, these are Python block. So again, standard library, you guys will be able to access so many things that are outside of standard library. There are things that are already part of the, like right there, for example, the print function. We don't have to import that. That just works out of the box. That's part of the standard library. Gregory, are you asking something to me? You can use the links. I'm just gonna mark it as answer. Let me know if you were asking me. So that is a really quick overview of Python and a few important things. We will be seeing all these in detail. For example, these string formatting, I'm going to show you that later. More libraries, you guys will be using them, etc. All right, so let's talk really quickly about variables and data types. This is necessary. I mean, I don't want to take anything for granted when you guys are working with your code, like here. For example, I'm setting now to datetime equals UTC now. In our guessing name, we're putting target number, like number 8. This is the number that should be guessed by the user. This is a variable. We're creating a variable. And a variable, what it will do, it will let you store something in memory, right? So you guys, I mean, again, this high-level language, and that's fine. It simplifies our life, but we shouldn't lose from our sight that at some moment this is translated back to ones and zeros and we're interacting with that computer. So variables, when we define a variable, for example, here we're setting the variable x, the name x to 3. Well, what we're doing is we're creating in memory, we're putting this value 3 right there in memory, and we're assigning a name to that variable, to that value, sorry. So we can then later reference it. What you will see from a computer is that it can't do too many things at once. It's like a robot, you know, if it wants to make the scrambled eggs, it can't hold two things in its hands at the same time. It has to get an egg, put it somewhere, get the pan, you know, put it somewhere. It can't have two things at the same time. This is going to happen also with our variables. We can't hold too many things at the same time, so that's why we store things temporarily in a variable, right? So here we're keeping track of the number to guess in our target number. So then we can compare that here, and we're referencing that by name. We're giving these things a human readable name. So then when we are reading this code, we can reference that. I could have very much said, put in the position in memory 1003, the number 8, and that's going to be the target number. But that would be really, really hard to read, right? What is easier to read? Target number equals 8, or in the position 1003 in memory, we have the number 8. That doesn't mean anything, right? So that's why we give a name. And again, a name, the only thing that it's doing is referencing a position in memory. So we'll be using these names to simplify our lives. I've said this so many times already, but it's the truth. We are using a human readable name so we can refer to a value, so we can refer to a piece of data from our human perspective. It's like, what is this number that I have right here in the middle of the memory? It's like I hide all these and all these. I hide all these to you, and you should see in memory number 3 what this thing represents, right? The variable name will let you make that clear. This number 3 represents variable x. Of course, next x doesn't say much, but a different name will say.
Oh, I just wanted to ask for my notes. If you go back to that REPL screen, what covers a block exactly? Like line 1 through 3 is one block, and then like, you know, 8 through 10 is another block, or some such, or?
Yes, yeah, good. So usually a block will be, in other programming languages, we have blocks that are defined, for example, with curly braces. So it's more clear the way to define them. In Python, we don't have that definition, but we do have them. Like, it's clear when we do have to put like indentation. So for example, I'm gonna go like advance on what we're talking right now, but for example, the if statement also has an else statement, this one right here. So we have if something happens, you are gonna do something else that didn't happen, you're gonna put something else. This is one block, the one that defines the branch of the true branch in this condition. Like if this thing is true, you're gonna branch here, and this is the block of the true branch, and this is the block of the false branch. You know, if this thing is not, if the guess number is not equals to the target number, you're gonna say this. These are the blocks that we're creating. So again, usually when you have indentation, you have a new block. It's nothing. It's not a highly imposed programming restriction. Aside from variable scope, that it's a little bit more advanced, it doesn't mean anything. Like, for example, if I put you, I say, if guess number is equals to target number, you win, that's it. Else, we're gonna say, if the guess number is greater than the target number, that means you're gonna say print too high. Else, again, too low. Too low. So now, for example, if I'm expecting 8, if I give up 10, it's gonna say too high. So if we are really strict, we have a block here. We have all this is an entire block, a second block, but this second block itself has one tiny nested block inside, two tiny nested blocks inside. So we have these, and these are blocks inside this outer, sorry, yeah, like bigger outer block that it's.
Gotcha. Okay, I'm getting it. It's like, okay, feel like a primary block and a sub block and a sub block, and just kind of,
yeah, exactly,
hierarchy.
You can keep defining them.
Thank you.
Yes, and that is, Gabe, that is a nested conditional. Yes, we're nesting conditions here. We also actually have an elif statement that we're gonna talk about this later, and I was actually going to use this example. I blew it, but yes, it's a nested condition. And again, blocks, they are not strictly defined. I mean, as long as they make sense to us as programmers, you know, to identify them, that's fine. Python is really cool because of that, because it's clearly seen when you have something happening. Like, this is pretty obvious. I mean, for someone that hasn't seen Python their entire life, like, this is pretty obvious that this is the nested block inside this if statement. But aside from some variable scope that, again, it's really advanced, not really advanced. We talk about, yeah, and it's not really advanced, but it's advanced. It's not going to have a real implication for us. So going back, talking about variables really quickly, I'm going to move forward here as fast as possible. We're going to talk about the elif in a second, Fran. The variables, again, it's just where from the, if you guys could separate this variable part in two things, you have the actual value of the variable, and then you have the name that you give to the variable. So we're storing the value 3 with the variable name x. The important part here is the value 3. This is what we want to keep track of. Is I want to search for a user's name. What's the username? The username is going to be something like search for user with name, I don't know, Tom something. This is the value. This is the important part. You're then giving it a label. You're labeling this data, so then you can reference it later. Then you're going to do something like a few lines, and you're going to do something like search database, you know, with this username. And you're referencing this. But important part here, again, is the data you're storing. You're referencing this label, right, to access this data. This is the important part. And again, all that is living in memory. So really quickly, let's see this example. Second line here, as I told you, we're referencing here x. So y is going to be equals to x times 3. So what is going on is that here x is just referencing the other value in memory. They are just like alias, you know, labels. This is going to give us a final result, you know, based on the value of x. And finally, we're printing y, sorry. and this is of course going to print just the value of y in memory, right? So we are referring just to y there. Make sense? Questions? We have a question. Yes, really good question too, Gabe. By the way, these things are really useful for me, guys, because to be honest, like this is the first time we do a course that it's starting with like these concepts for like beginning concepts. So we will forget a few things. So just let us know and ask us. Yes, Python, it's the same thing as doing, I don't know, hello world with double quotes or doing hello world. And also, I referenced this really quickly when we started. We also have a multi-line string. So it's going to be with 3 quotes, hello world and hello world. You know, these are now, or let's say bye world. This is a multi-line string. I can assign this to a variable like greeting. There you go. I can print this greeting. I will keep this out so I don't see it. There you go. I'm printing a multi-line string. So either single quotes and double quotes, they are the same. And you can do multi-line strings. Of course, this can also be used to create a just one-line string. It's not really convenient, but still, as I mean, 3 quotes will mark the beginning and the end of the string, a single quote or just a double quote. So yeah, thank you for the question. These things, again, are valuable and useful for us.
Hey, Santiago, what's the difference between a multi-line string and a block?
A block will be a set of instructions. So you will put here a set of different instructions to make. Like sadly, we're dealing with like examples that are too simple, but usually each one of these branches will have many, I don't know if many, but several lines to be executed. You know, it's not like you will put just one line after an if statement. It's like in this case, this whole block has 1, 2, 3, 4 lines. So a block will be just a set of instructions of statements that itself, like each one of these statements can be another conditional, another loop, etc. A multi-line string is just text, plain old text that you want to express in multiple lines. Make sense, the difference?
Yeah, thank you.
You're welcome. Yes, we said this. So three quotes will also be used for commenting. It's not actually a real comment, but it's a quick and dirty way to get something commented out without any like real implication in the code. And Mark or Marco, how do you print quote or quote? I don't get the answer, sorry. Maybe rephrase it. All right, moving forward. We saw variables. We are storing data types in those variables, right? So that's the important part. Global variables versus local variables. Good question, Rashid. And it also has to do with scopes of variables. That again, it's complicated topic. The truth is that everything is going to be a local variable, right? Except you mark it. Well, scoping in Python is complicated. Yeah, let me just put it in that way. We can say that for reading, everything is going to be global, but for writing, everything is going to be local. And again, it's a complicated topic. And how do you, so how do you escape things in Python? You can put if you want to put another quote here, you can just put a backslash. There you go. And now let's put a number too low. There you go, too low. We're having a quote embedded in there. All right, so you guys are answering questions by creating more questions. All right, let's move forward. Data types. We're using variables to store data, right? But this data is not just like, it has some sort of of characteristic, right? So we're gonna define data types. I'm gonna show you really quickly what this. I'm usually pronounce it data types, but then I say data. I don't know why. Sorry. Data types, so I can be more consistent on my pronunciation. So a couple of things we're gonna do with data types. Remember when we started the class, I told you that a fact from life here in computing in general is that computers only know about bytes. So when we do something like, I don't know, name equals Mary, we see here as human beings, I am reading this code and I see, oh, look, this is text. You know, I could write this algorithm in a piece of paper. But if I run this algorithm, store it in a hard drive to work on it later, send it over the network, I do whatever thing with these will be translated to ones and zeros. So these data types, what we see as a string here, arguments and parameters, yes, we will talk about that later in functions, but there is no, I think, difference between arguments and parameters, but we're going to talk about functions later. So data types, as I was saying, we are storing a data type like a string. We're going to have different data types. We're going to talk about them in general later. Strings, integers, we have a number here. This is a string, is pretty common. Now, again, we're expressing a name or a text, right? It's just in human readable language, I put Mary between quotes here, and this marks some text, which is a string data type. The idea of a data type is just, again, to simplify our lives, because the computer will only know about bytes. So we could very much, instead of using data types, right, we could use ones and zeros, binary code. We could, if we are faced with the challenge of concatenating A, B, and C, we could very much use bytes. In Python, it's just this expression in bytes will be getting the string A, getting the string B, and finally putting together the string Z. Now, what if I ask you something a little bit more complicated? Check if a given substring is part of a given string. So if I give you Mary is from London. If I ask you, like reading this algorithm, is London, the word London, present in this string? You will tell me that it is, because you know how to read. If I show you a byte representation of that, you will not know what I'm talking about, because bytes are hard to read. So data types, they are just a bridge for us to communicate with the computers to finally express ones and zeros in a higher level language. So we are not gonna put ones and zeros. We're gonna write Mary is from London. We're gonna write is London part of this string. We're gonna write A plus B, 3 times 4, 2 to the power of 5. We're gonna express things in a high level language, and data types will serve that purpose, help us in those processes. This is the idea of data types. There are many different data types, right? The most common ones are integers, right? Or numeric types in general, integers or floats. Should open a new REPL here. I'm gonna do it in a second. Here. There we go. So we can have, I'm gonna just use this part. So I can do, for example, 3, this is an integer. I can actually check for the type, check for the type of this value, right? And it's gonna tell me that it's an integer. I'm gonna check, I'm gonna do a float. I'm gonna do 3.5. This is a float. So if I check the type of this, it's gonna tell me that actually it's a type float. There are many different types of integers or of numbers, and there are many ways to express numbers in Python. So for example, in Python 3, I can do 10,000, or I can do 10,000 divided with an underscore, and it also works. It's the same thing. Like 10,000 is the same thing as 10,000 separated with an underscore. It's just a different way to express something. I can do also 1 minus 1. There you go. So I can express it in exponential notation. There are different ways of expressing the same value. And if you guys think about it, I'm really repetitive about this, sorry. This is just ones and zeros in the computer. The difference is that we're expressing it in a different way. We're expressing it in a language, in a notation that it's more familiar to us, you know, and that's a good thing. We're writing human readable code. Numbers, they're really common. Integer, floats, the most common ones. We also have strings, right? We can put text in strings. This is text. This is text. Again, single quotes, double quotes, triple quotes, same end result. In Python, we have an issue with Python 2 and Python 3 regarding strings because of the difference with Unicode and bytes and strings. And in Python 2, we had a simple string and Unicode. And in Python 3, what was Unicode in Python 2, now it's string, and now we have a new type, which is bytes. It's really confusing, really complicated. It's one of the bad parts about Python, how complicated it is, but the final result is really good, how Python works with Unicode and bytes. But it's a more advanced concept. Sorry, I have a couple of questions. Yes, Gabe. An integer is a whole number, and a float is going to be a decimal. By the way, thank you. Good question. The issue with complex numbers, no, that's the other question. With floats is that they are not like super strict floats as we know them. If I do 0.1 times 3, I get a really ugly result. You know, we know that 0.1 times 3 is 0.3. This is pretty close to 0.3. I mean, it's 0.3000004. So if I round it to how many places, like 2, 4, 8, like 12 places, it's still 0.3, but it's ugly looking 0.30004. There's actually another library called decimal in Python, part of the standard library. From decimal, import decimal, and I can do decimal 0.1 times 3, and now I get a better result, you know, something that I'm used to see. So yeah, floats are numbers with the decimal part, and integers are whole numbers. And complex numbers, HP, I'm not really sure, to be honest, so we should check it. I have never worked in my entire life with complex numbers. I don't do any type of scientific programming, so I'm afraid I haven't worked with complex numbers. I do know that there are ways to work with them, so we should check it. Tyler, yes, a decimal is the library, and the decimal is actually a class, like decimal with a capital D. It's a class. Doesn't matter that much now. Gabe, I don't know if it's beyond the scope of the class. It's a good question about it that HP did asked, sorry, and maybe someone else have it. So if you guys can like keep digging on that, it's a good thing. We don't have all the questions. We have 100 people right here, and you all have different backgrounds and different interests. It's impossible for me to know everything. It's impossible for just one single person to know everything. So we can keep like I could make the choice to say we will not cover that, and that would be easy. But no, let's just, I mean, if you guys are interested, we should dig deeper on that, and you guys can create a study group, sorry, and keep digging on that. And Rash's question, I don't remember Rash's question, to be honest. So please ask again. Andrew, are you asking if is decimal is a function? All right, so moving forward. We were talking about strings. I went back to decimals, floats, and integers. We also have another type, which is Boolean, right? That will express truthiness and falsiness in a real clear way, like true and false. So we can say something like, is active equals true, you know? Booleans are tricky in Python. You know, we have a blog post. If you guys check our blog, you will see why Booleans are tricky In Python, they're actually integers down there, you know, under the hood. But anyway, that's it. And finally, something that I'm forgetting from here, I'm gonna fix these slides after this class, is the none type. None. None is used to symbolize void. There is nothing here. I don't know how to express it. This is none. Actually, if you guys like history of computing and programming, none comes from null. You know, we have null in other programming languages, and this has been called the $1 billion mistake. If you guys Google it, null $1 billion mistake. Oh crap. $1 billion mistake. This guy created null, and he then said something like, there's the word, I made a worst mistake in computer science, I created null. It gives us a lot of headaches, you know, null references and all that. But still we have a none type, which is similar to null, and it symbolizes nothing. Like, what is this result? Like, I don't know, you have a function that search for a user. Search the user with email something, and if the user is not there, you can return none, for example, or you can return an empty list, but just whatever makes sense for you, and none will just help you with that. A string, well, if a string is a decimal, no, a string is not a decimal, it's a string. All right. So a couple of data types, and again, the idea of data types is just to help us interact with the computer in an easier way. Operators. We're going to talk really quickly about operators, because combining data types with operators with control flow structure that we're going to see later, we're going to have close to an algorithm. Operators let us just operate on data. Duh. I mean, there's not much about it. And we roughly have like these 3 categories of operators, you know, like math operators, Boolean operators, and assignment operators. Assignment is what you...
Can I ask something here? There was in the first little test on your documentation, like when we first got started with that class, there's a little test about you like would write your name, and the method was in forest green. Is that an operator?
I think it's this one. This one?
Yeah. Oh, sorry. Format. Yeah, the format was that an operator some kind, or am I a little off?
No,
okay.
It's where I was actually going to reference these after this, but let's just do it because it's related to data types. So really quickly about formatting, this is important. What is going to happen is that sometimes you have some text that you want to create, right? And usually that text will be a combination of some fixed /template text you have. Like let's put a real example. You guys want to send an email to a user, and you want to build a subject, customizing it with your user's first name. So we're gonna say something like, hello, Sean, class is starting in 5 minutes, right? So this is what you want to send to your user. This is the subject that you want to create, so then you can send the email. You will do these for all your users, so these will come from some dynamic data. So you will have user's first name equals to Sean. You know, somehow you got this user from a database or somewhere. So finally, you want to combine these 2 pieces of data, the dynamic part for each user with the fixed /template part you have. To do that, you could very much use just operators, like math operators that also work for strings, to do something like print. We can do something like hello. I'm going to copy these. Hello, close the string, do a plus, user's first name. There you go. Plus, don't forget the space. Class is starting. Let me put this here. Class starting 5 minutes. There you go. So now it works. And now we also want to make these dynamic. So now we don't know how many minutes we have until class. We're going to take it out. I'm going to say minutes. It's going to be 5. All right, so this is also going to be dynamic value. And here I'm going to close the string again. I'm going to open it again, you know. I'm going to put 2 plus signs. This is really ugly. You guys are starting to feel why we need this format right here, right? It's like this much clearer. But still, let's continue with our example. Let me break it down to different lines so it's easier to read. Yeah, put this there. And now I'm going to put here the minutes variable. So these are final string. We're just doing like a mathematical operation. It's not math, but we're concatenating strings to build our final version, combining some fixed string with some dynamic data. If I run this, and I need a space here to show you the ugly error we're going to see, we're having an issue. We're having a bug. And the issue here is that minutes, it's actually an integer. And this operator works for strings. Like it's good to do 2 plus 2. It's good to do, I don't know, hello plus world, because this is an integer, and this is an integer, and this is a string, and this is a string. But the two together, like 2 plus hello, can't be achieved because this is a string and this is an integer. It's like adding apples to oranges, traditional example. So that's why this thing is failing. So to make this work, what you should do is translate minutes to a string first. So if you have a number, let's say 10, and you want to turn 10 into the string representation of 10, what you do is str of 10, and gives you the same thing, but now carefully you read here that he has quotes. So this is actually a string. So we have to turn minutes to a string first, and now it's going to work. Now, I think this is pretty obvious up to this point that this is super ugly. There is a better way. We're gonna build like template strings. We're gonna say that these are fixed template, right? This is a fixed text we wanna put. And then we're gonna say that we are gonna put some dynamic data inside this string. That's gonna be, of course, replaced with the variables we're gonna pass. So for example, we're gonna say hello, and here we're gonna say, I'm gonna pass here a user, or a name. I'm gonna pass a name here. I don't know what it is yet because I don't have the dynamic data. And then we're gonna do classes starting in. I'm gonna put here min, just because I want. And I'm gonna say here, this is my final string. We'll have this is fixed, this is fixed, this is fixed. And then I have a couple of placeholders, sorry, that will be filled or completed with dynamic data. So I can do now, I'm gonna just leave this one here commented out so you guys can compare it side by side. I'm gonna do print. I'm gonna combine the subject that I had. I'm gonna format using, sorry, I'm gonna use the method format. I'm gonna pass here for name, use user's first name, and for min, use minutes. So here you're saying this placeholder you have right here, fill it with this variable. And this placeholder you have right here, and the placeholder is created with curly braces, fill it with these variables. So now it works as expected. These are named placeholders. You can also avoid putting a name, and then you will just pass the data, and these ones will be replaced just in order. This variable will complete the first placeholder. This variable will complete the second placeholder. Make sense? So Abel, the string method was turning a number. It's actually a string method will pretty much take anything. We can pass anything to a string, and it will process it and return a string. But the important part here was that we were creating we were passing a number, and it's turning it back to a string. And why? Because if you want to combine, today is class 21st plus Steve, this breaks because you can't add integers or numbers to strings. You have to either are all integers or all strings. So before doing that, we turn 21 into a string, and this doesn't fail anymore. Make sense? Questions? Sorry, I diverged a little bit with the format, but it's an important thing to do. Got it completely, but can you do a quick review? Just a quick summation to reinforce it? Yeah, sure. So the idea here was to, well, 1 second, there we go. Anonymous R&D, I don't know what's the name here. Good making templates be a good way to practice, or is it redundant since the library is there? It is actually a good idea. Yeah, building a template engine, it's hard. I bet it's hard, but it's a good idea. So quick summary again. So the print method can only print strings. No, the print method can print whatever. 323. It's actually turning this thing into a string and you don't realize. Why we needed to turn the number to a string was, I'm gonna put it this once again here. If I do hello space plus world, I print this is gonna work as expected. If I do print 2 times 2, it's gonna print 4 as expected. So I can add two strings, and I can add 2 integers, integer to integer, string to string. I cannot mix them. I can't do hello plus, plus 10, because this is an apple and this is an orange, so it's not gonna work. It's gonna fail. So I have to manually turn this thing into a string. And this is also helping me like revisit these topics for fun. The idea here is that if we want to build a string that it's a little bit more complicated, instead of manually concatenating strings and typecasting things to strings, we can use the formatting one. So we are specifying at some, you have like 2 things in this recipe. You have the fixed template, this is fixed, and you want to combine that with some dynamic data. User's first name is dynamic and minutes is dynamic. So you will put a template and you will say, you will specify a set of placeholders that will be replaced then with your dynamic data. So here you're gonna do hello, the placeholder, classes starting in placeholder minutes. So then we're gonna take this thing out, you can then combine all together the fixed template with the dynamic data, and all together will form the final string that we're seeing right here. And I could actually store this thing, and this is going to be a subject template, we're going to call it, and the actual subject is going to be subject template dot format this. Oh, didn't print it. So finally, I'm going to check the subject. There you go. And I see it's combined. I can change this data. I can put Mary here, and it's 3 minutes now. And it's combining Mary, hello Mary, class starting in 3 minutes. It's combining again the fixed part with the dynamic data we have and we're passing. And again, this relationship or this combination is being done by order. We have the first placeholder is going to be filled with the first piece of data we pass. The second placeholder is going to be filled with the second piece of data, or second variable we pass. Make sense? Defined by the fact that they can be mathematically manipulated. Catherine, it's a good question actually. Are strings defined by the fact that they can't be mathematically manipulated? Actually, strings don't have any math. I mean, we are not, when we express, and I'm going to tell you in a second why this is a really good question. When I say something like print a plus b plus c, I'm not adding, like summing characters. What I'm doing is concatenating them. I am concatenating one character to the other. And it's not a mathematical operation. It's a string operation. And the takeoff from here, or takeaway here, is that the same symbol, the plus symbol, will mean something completely different depending on the data type. For numbers, and here important, it's not just integers, like for example, 10 plus 0.5, the plus symbol symbolizes addition. I am mathematically adding these two values. For a string, the plus symbol symbolizes addition, concatenation. And they are completely different notions. And it's important because this is really advanced again. I don't want to get into this, but you guys will, in Python, you are able to define what a plus symbol represents for your own custom types later. But the important part here is that's also a good thing about data types. They will give you these goodies. Like the plus symbol will symbolize something completely different for a number than for a string. For a string, it's concatenating characters. For a number, it's going to be a mathematical operation. What if you did print A plus B plus C without quotes? Good question, Gabe. Good question, because let's actually do it. If I do print A plus B plus C, Python is expecting these things to be symbols that are somehow defined in the language. I'm going to run it just for you to see the error. So it's expecting these things to be symbols, special symbols. Usually these things are going to be variables. Like A is going to be, I don't know, hello. And B is going to be goodbye. Or it's going to be a dash. And C is going to be world. So if you don't put quotes, these things need to be defined somewhere, either variables or imported. We're not seeing imports yet, but they have to symbolize something. And usually it's related to this right here. Just a symbol, it's a symbol is, oh man, Gabe, it's a great question actually. A symbol, it's like this this value, this label you're expressing, right? And it should be defined somewhere for Python. Usually, again, we're creating a variable, so we're defining that the x variable, defined by the x symbol, it's actually pointing to the value 3. So then we can use A here because we have defined it before. But if you don't define them, Python is not finding these symbols anywhere, and it's going to fail. Make sense? So alien PASB, that's usually handled with a collection or with a list. We're gonna talk about those on our second unit, on our next week, by the way. So you will create, instead of having just one name with 1 minute, you're gonna have multiple names stored in a collection, right? A collection of names. It's gonna be a container containing all those names, and then you will be able to iterate over all those names and do something with them. In this case, for example, printing the subject. All right, so moving forward, operators. We were having different types of operators. I think we have covered pretty much this plus operator, which symbolizes different things for numbers and integers. We also have assignment operators. You guys already saw how to create a variable, how to store something in memory. Remember, we need to create variables because the computer can't handle too many things at once. So we will be putting steps like get this thing, put it there over the desk for a second because you will need it later. Now go do this, and now go back to that thing you stored and use it again. So that's what we're doing right here. We're storing the value string hello in the variable x. We're then referencing the value x and adding something, and all these things going to be stored in the variable y. And finally, here is another assignment it's actually this is a Boolean operation. And here I want to focus for a second in Boolean operators. Boolean operators are these things we can actually store in variables. I can do, for example, result 1. I'm going to do 3 greater than 2. It's like a question. Is 3 greater than 2? I'm going to print what result 1 has. It's true. I'm going to do the same thing now with different than 2. Is 3 different than 2? Yes, of course it's different. I'm going to do the same thing. Oh, by the way, I'm like renaming the same variable. Doesn't matter that much. I'm going to do the same thing now with is 3 different than 3? So what is this going to answer? Is 3 different than 3? No. What's our coding version of no? False. So is 3 greater than 2? Yes. What's our coding representation of yes? A true value. 3 different than 2? No. Oh, sorry. Too late for me. 3 different than 2? Yes. What is yes? It's true. 3 different than 3? No. So it's a false. And here we have many different operators and Boolean operators. For example, I have is active. Active, I search for something in our database and I have a final result. Is active? False. The user is not. User is active? False. What was false for us? No. So is the user active? No. False. So I can say something like not user is active. This is a Boolean operator too. Result 4. And I can print this result 4. And I want to hear and I want to read it. What is this going to print? User is active is false. So not user active, what is going to print? True. And this doesn't, I know that this doesn't make much sense here, but if I express it in an if statement, if I do if not user is active, print user is not active, else print user is active. So here it will make more sense. User is not active. Here the not operator has a special meaning. I'm going to talk about it in a second, but more importantly, it's the intention of the not operator is to respond to English language. If not is user active, we could kind of put this thing, user is not active, could read similarly. Like if user is not active, if the user is not active, right? We have to express it in this way because we can't break the variable in the middle, but we're expressing the same thing. If user is not active, right? User was active? No. So this matches the condition. If the user is not active, don't send the email or log it or send a confirmation email. Do something here if the user is not active. Put it simple and a good mnemonic here, I want you guys to focus on the concept. I want you guys to think about these things, not to do it mechanically. So that's why I'm explaining this in this way. But there is another way to think about the not operator, and it's that not will just flip whatever you have. So I'm gonna comment these ones out, not comments, but still. I'm gonna do print, or here I can do it here. Print. I can do not true. It's gonna give you false, and not false gonna give you true. So it's just flipping the value you have. All right. So this is a good mnemonic for you guys to remember for now, but try to think it in the semantic way. Not user active. Not greater than 30. Something like that. Questions? I have 2 questions. Would 3.0 be different than 3? It's a good question, Kyle. I assume your name is Kyle. It's a really good question because 3.0, if we speak on a mathematically from a mathematical standpoint, it's not different than 3. So 3.0 equals to 3? Yes. If 3.0 or 3 mean different things for us, then this question might give you different results. So 3.0 as a string is different than 3 as a string. So depending on what you're asking is the result that you're going to get. And if you're just asking about numbers, no, they're the same. When using subject template.format, the data inserted within the parentheses automatically inserted into the placeholder based on what behavior? Here, it's just order, the order. We have 2 placeholders. We have here 1 placeholder, 2 placeholders. We have 1 variable to replace, one variable to replace, second variable to replace. So this one corresponds to this one, and this one corresponds to this one. Just order. They are matched by order. And yes, second question from Jesus is, how is it like, oh, no, I thought you were asking something different. If you could replace variables, like for example, if you could put here minutes, and it would match automatically this variable here. It's actually, I don't like that feature, but it was introduced in Python 3.6, I believe. I don't remember the name. I don't like it, but you can do it. No, Adrian, it doesn't have the triple equal, because it's not that broken as JavaScript. The exclamation mark, Stefan, doesn't exist in Python, I believe. Yeah, there you go. Doesn't exist. This is usually related to JavaScript or Java. In Python, we have the not one. In JavaScript, you would do something like not something. In Python, I mean, like, this is not readable. Python tries to be a readable programming language. So here we have not something, not true. Will the 3 still result convert to? Oh, good question. So we had a question before that if 3, I think was Kyle, if 3 was equals, if 3.0 was equals to 3, and yes, it is. But what happens? Remember that if we do 0.1 times 3, we get 0.300004. Is this equals to 3? Is it? No, it's not. But then, I mean, like from a super strict standpoint, it's not the same thing. Then we can check it. Like, for example, let's do just the mathematical check. Is this thing equals to 0.3? No. Now, if I tell you, hey, can you give me 30 cents? These are 30 cents in dollars, in US dollars. Can you give me 30 cents? And you say something like, or sorry, you owe me all these cents or all this money, and you give me 30 cents. Will I get picky and say, hey, you owe me like, I don't know how many decimals of a dollar? No, this will not make any difference for me. Now, if we're talking about the price of Bitcoin in 2020, and a Bitcoin is worth $1 million. Now this number here might make a difference. So it depends on how you guys are checking. Strictly speaking, they're not the same. But then you can do different types of operations, specifying like a tolerance window. Will third place result in no variable and no value? Ryan, good question. If you have 3 placeholders, but you define only 2 in format, I think, good question, because to be honest, I'm not really sure. I think it's gonna fail. You should check it, actually. I'm just gonna put a new placeholder here. I'm gonna see it. There you go. It failed. If I put something else here, man, there you go. There you go, worked. So yeah, it fails if it doesn't have a placeholder. And actually it's pretty annoying. I knew it failed because sometimes you wanna like partially replace it. Like you wanna build your string in different parts and replace it partially. And Python doesn't allow you to do that. I think there is a new feature in 3.5 or 3.6 that lets you do this. It's kind of annoying. Can you limit the number of digits on a decimal? You can round it, you can seal them, you can floor them, you can do like import math, and then you can do math.floor. You can do 3.7, for example. We'll give you a floor or zeal. For you can round things. Will be close. Or round actually has more parameters, like if it should round to the greater one to the lower one. There are different, more advanced things to do. All right, so Boolean operators, we saw them. We have greater, equals, we have greater and equals, right? Like if x is greater than 3, or greater and equal than 3, we can do all these things. And finally, here, where do we have our conditional? Right here. So we're going to talk really quickly about two things to wrap up today's class. The first one is, I think we have covered this pretty well up to this point, is conditionals. And then we're going to talk really quickly about functions, how to use these functions. Conditionals. We're going to go back to our original code. And let me put here the previous version, print you lose. There you go. So guess a number. The number that I'm expecting is to be 8. I'm going to guess 9. So I'm going to lose because target number is 8. My guess here is 9. So guess equals then my target number. If it is, it's going to print you win. As it is not, it's going to print you lose. Each one of these blocks, again, you can do pretty much whatever you want. That's why we had actually like a whole different block inside here. That's how this thing worked. So here, if I put a 10, it's going to give me that it's too high. It's not that I lost, this block. Not that I lost, I also evaluated a new block inside this thing. If statements in Python have not just if and else, but they also have an elif different statement, I don't know how to call it, that will let us do this thing in a better, more readable way. And it's a different case. So I'm going to write it just below this so you guys can see it side by side, like compare it. I'm going to put it separator there. I'll write the same thing, but it's going to be something like, if guess equals to target number, that is it. You win. I don't have anything else to say right there. Else if guess is greater than target number, I'm going to print too high. Else, I don't have any case. It's not equal. It's not equal. I'm ruling that option out. It's not greater. I'm ruling that option out also. The only one that I have left is that this thing is too low. So here I'm going to put print too low. Guess the number. We're going to with a low one, 4. Too low, too low. We're going to go now with a large one, too high and too high. Make sense? Questions? What if guess equals 8.0? It's a good question because what we're doing here is we're asking for input. We're asking for input from our user, right? So here, Python is asking me something. I am running this script. I'm gonna stop it for a second. I'm gonna put print 1, line 1, and I'm gonna put here line 2. And I want you guys to see something. When I run this script is like stopping right here. It's halting there. and it's waiting for my answer. This is not something that we usually do. So let me start from there. There are two things that we don't do in any professional code, and it's input and print. And this is what you guys will do a lot from, at least in this course and in the ones that follows. It's like you will put inputs and print all the time because you want to see something. You want to see your code. You want to see that it works. Let me cut it clear right now. In any professional Python code, you will not see an input and you will not see any print statement. Actually, they are bad things to have. They are, we call them smells. If you guys have a print statement, it's a smell. But just to be clear. So again, execution is stopping here. I am trying to answer the question about 8.0. What is going on is that I will put something here, and this is going to be evaluated as a string. So let me show you right here another example of input. I'm going to put a value. It's going to be input. Try any value. I'm going to print the value, and I'm also going to print the type of this value. So here I'm going to print the type of this value. Input. My bad. Try any value. So I'm going to put 9. But 9, as this thing is from the user's input, it's a string. So then we're turning this string into an integer. We're forcing it. We're typecasting it. We're causing it to be an integer. We're turning this thing into a number. We receive a string from our user and we turn this thing into a number. So for example, if I put 8.0, 8.0 will be turned into an integer. Well, we have an error because of Python 2. And it will, in this case, it doesn't work in Python 3, but it will be turned back into an integer, and then it's going to be evaluated. This has to be to do with how we, if I put base, with base, it will be float. There you go. Let me put these to see if it works. There you go. What I'm doing is I will end up coursing everything to an integer, so that's why it's going to be the same thing as this. Usually, if I'm expecting a number to expect for a float, is going to be safer than expecting for an integer. How do you make sure the user only inputs a number that is not a decimal integer, but only whole numbers? Robin, it's a good question, and actually there is a really popular answer in Stack Overflow about that. And this will let me introduce a couple of things. The first one is that we Google things, you know, and like Python check if numeric. I do this all the time. That's why I've seen this question too. Actually, is it clicked? I can tell if the color is clicked. So there are different ways to check this. There is a is numeric somewhere. You can try turning something to a float and see if it fails. So this is more dealing with exceptions we're going to see later, but something like if you try to turn, so float of 8.0 is going to give you a valid value, but if you pass an invalid value, it's going to give you an exception. So you can catch the exception, and there are many different ways to do it. There is no simple way to do that. So to answer, Robin, your question directly, there is no simple way to do that. And actually, handling users' input is really complicated. And again, this also lets me introduce the second topic, that is we Google things all the time, you know. All right. We're pretty much done with today's class. I'm going to show you two more things. The first one is this thing. I wanted to actually start with this, but as people were shining late, I didn't want to blow it like in the beginning so everyone could see it. There are two main things of running things with Python. You guys have seen some of them. The first one is creating a script. So we'll create a main.py, for example, main.py. This will create a script right? And again, I'm using Cloud9 because it's a simple way to show it to you, and I don't have to deal with any sort of platform. This works in any platform that you guys want. And I can put my script here, so I can, let me copy this code. I'm gonna put it right here, and then in Cloud9, I'm gonna save this file, I'm gonna run it. Guess the number, it's gonna be 7. There you go, too low. Another way of running Python is with the REPL. All right, so I'm just gonna type Python here, and it's gonna kick off a REPL, which is the same thing we have right here. It's actually the name of this site. REPL stands for Readable Print Loop, I believe. And the idea is that you can just execute commands really quickly. We do this all the time. For example, I don't remember how the random function work. So I could do something like from random import rand int. I can just try it out. Rand int 0, 100. Oh, there you go. That's how it worked. Now I remember. So it's a quick way to evaluate something. I use the REPL as a calculator all the time. So it's just a different way to run something. So scripts, you will save the file, you will execute it. You can also do something like Python main.py if you have a terminal or a console. 8. There you go. Or you can, if you're using an IDE, you will usually have a way to executing things dynamically. We recommend you to create a Cloud9 account as soon as possible. We're gonna write about this later. Really quickly, try to create a Cloud9 account. They are free. They will ask you for a credit card, but they will not charge you. If you guys don't have access to a credit card, we will send you a private invite. We will actually write about this so you guys can request our invites. We don't have those many invites, so we need, like, just here, be cool. If you do have a credit card, don't worry, they will not charge you. Try to create it on your own. If you don't have access to a credit card, we will give you an invite from our own team. All right, but they cost us and they are limited. So that's simple advice. And finally, we're wrapping it up. Have a question? Yes, Tyler, definitely. And Python is Linux is the best friend of Python. It's like and actually that's why we encourage you guys to use Cloud9, because Cloud9 underneath this thing is a Python. It's a Linux environment. It's a virtual machine running an Ubuntu distribution. So it's totally fine. And actually, we encourage you, Windows users, Mac users, to start working with Cloud9 because Python works on Linux. Web servers, data servers, everything's going to work on Linux. So having minimum handling of Linux is important. And finally, I'm going to talk about really quickly about functions because I know that you guys will have issues. We have a good, decent explanation about functions here, but still it's important. So I'm going to talk about invoking. So here again, reading, but we have invoking functions. This platform will ask you many times to start your assignments with functions. And when you do functions, there will be a difference of you will be returning things. So here, for example, a lot of you will do something like print. Here, my name is Santiago, so I'm going to do this. There you go. And you can test this code right here. And I'm going to do this. And this seems like it's working because I see my name. But it's not actually working because this function needs to return. And the way to do that is just by putting a return here. By the way, if I do the same thing that I saw working, like with my human eyes, if I run the test here, well, this one failed because it's none. But if I, oh crap, we're making this assignment too simple. I'm gonna put a new test to fail for this one. This value actually is none. It's returning none. So you guys have to return things from your functions. I'm saying this because most of you will start working with this, which is a really good thing. We will cover functions in more details in the following classes. But still, it's important to understand the difference between return and just printing inside your functions. As I told you before, a good professional Python code doesn't have a single print statement. All right, so try to avoid print statements. I mean, this is gonna give you a reference if your code works. This test we have right here, it's also gonna give you a quick reference if the code works or not. All right, we're gonna update all these, and you guys are seeing them right here in the assignments.
What does it mean to return?
I don't want to like blow up all the concepts from second class, but basically what you're gonna be doing is you will create a function that will be used by another function. So by an external resource. So for example, you have a string. Let's say we have a name here as Mary, and there is a built-in function. It's the len function. The len function will give you the length of characters of the string Mary. This is a function, and what it's doing is returning something, so you can then store that value in a variable. For example, you can do the length of s is the len of s, and here you're storing in the variable length of s the length in number, the result of this function. So this result will be assigned to this variable with a return. So here, if we have like, if I do like def add, let's do an add function, super simple, x and y. I'm gonna do, for example, print x plus y. I'm gonna do print the result of 2 plus 3 is, I'm gonna first compute it. Result is add 2 plus 3. I'm gonna do print now the result. This will say the result of 2 plus 3 is none, because I didn't return anything from this function. So res is equals to none. Remember, void, none is used for void. So here what is going to happen is add returning nothing, so res was assigned to nothing, and I can't possibly use this variable here. If I, instead of printing, just return this variable, return x plus y, I will be assigning this value to this. So return will assign the result of this function. The return will signal the result of a given function, and this return will be assigned to res. And now it will work as it should. The result of 2 plus 3 is 5, and 5 comes from res, and res indeed comes from the result of 2 plus 3. Again, we are gonna see all these in detail. I just want to give you like a hint. If you guys are working with these assignments, you will have a few errors related to that. Nothing to be afraid of. The important takeaways from this class is, first of all, again, we're still updating this platform. I'm going to upload between today and tomorrow a few more lessons in videos. We're going to split these assignments. There are too many assignments here, so we're going to move them to our second unit. You guys should like focus on the reading lessons and try to do the first individual assignments, and then again, we will be like fixing them on the go. And important again is operators, like all the things we see here. Where are them? Here, right? Operators, conditionals, and all the time, everything about variables and data types. All right. Any questions? This is pretty much it for today's class.
Is there some kind of like set of due dates for every section, or every like how far should we be by next week?
No, and actually it's a good question, because so what happens, this also happens in the intro course. These things, it's really hard to come up to a good baseline for every student, because these topics are maybe for some, I don't know, someone started computer science in college 5 years ago, and this is like that person reads really quickly, and this is a piece of cake. For someone else, this might be the first time that they see it. So it's really hard to come to a baseline where you say, turn all this assignment in, because I might be like bothering someone, and it might be too short or too low for someone else. So what we say is just fill these assignments, try to do them all. It's like go like every 3 assignments and try to do them. Do they work? If they don't, it's like you need more work, keep doing them. If it's simple for you, you can just skip them. So there is no hard deadline for them.
Thank you.
You're welcome. And yeah, you can ask Alien PSP. Sorry, I don't know your real name. You can ask Martin if you want. Yeah, you can email him. And mborkers in Python, double ampersand and double pipe for or and n. Yes, they are replaced by their English counterparts. And actually, when you guys see ampersands, pipes, and all that, those are usually bitwise operations dealing with bits, and we will not, like ones and zeros, like shifting bits around and all that, we will not see that because it's more advanced. And Tyler, when I say it's a high-level language, is exactly that. You're expressing things in an English language. You know, it's not like you're writing ones and zeros. You're saying like, if this thing happens, A plus B, and that will concatenate something. It's high-level language. It's hard to answer this if you haven't ever seen something coded in a low-level language. But a low-level language is gonna be something like this. You know, like you will see ones and zeros, or assembly language. You know, like store in this register in the CPU something and take it out, and you know, it's much more complicated. You guys that you're saying, if you're saying programming for the first time, everything's going to be a high-level language, because it's really hard for you to go around for everyone. It's hard. We don't see low-level languages that much anymore. C, for example, is a low-level language in this regard. It's a high-level language, but it's lower level than Python, because in C you have to like manually handle the memory. I'm gonna put this variable here. I'm gonna clean up the memory. I'm gonna reserve this chunk of memory for something. It's lower level. It's still high level, but it's lower level than Python. Robin, you can use the Python template. When you guys create a new workspace, I'm gonna show it to you right now. So let's do something. Today's class is over. Those of you that want to go and get something for dinner, go with family, it's fine. Today's class is over. I'm going to answer a couple more questions. How many people present right now? 88, including, I believe, Martin. So, and I don't know if counting me. So probably 86. From the couple thousands we got signed up, it's a low number. So here I told you, programming is hard. So I'm gonna show, Robin, thank you. It's a good question because this might be useful for some of you. Why am I logged out? So Bill, in Python, your main concern with memory is deleting variables to prevent memory leaks? No, we don't care about that, to be honest, because Python is a garbage collected programming language. So we don't have, I mean, if your code works correctly, you shouldn't expect memory leaks. If you have a bugged code, you will have memory leaks, of course. But yeah, usually we don't care about memory at all. Except with really like more complex applications when you can use weak references for memory and all that. So answering Robbie's questions, when you guys are creating a new template, you can select a new cloud and workspace. you can select a Python template, and this will have many different tools pre-installed, and it's a good idea to use it. Between different data types within Python, for example, int to float or float to decimal. Ryan, it's a good question. Usually, you're going to use the primitives like int, float. So, for example, if you have an int 5, you can turn it to a float with the float function. Float 5. It's going to turn it into a float. Or the other way around, you have 5.0, and you want to turn it into an int 8.0, so we don't repeat the number. You want to turn this thing into an int, you will do int of 8.0. You will turn it into an int. Int, float, string, str, int, float, sorry. They are funny, to say it in a way. They are special because they are both the type and the function, and this is confusing. If I ask for the type of 5.0, it's going to tell me that the type is float. If I do the type of float equals float, it's going to tell true. So float symbolizes both the type, and it's also used as the function to turn something into a float. So that's kind of confusing. Gregory, are updates to the lessons going to invalidate the check marks indicating completion? No, we will just move them around. It will not change them in any way. By the way, I hope you guys are happy with today's class. Sorry, I said it's our first time with these amount of people. Hope you liked it. Please give us feedback. We have a couple of guys dropping, but we will keep we will try to get help from you. So we will create teams, and we'll have like team captains, or I don't know how to call them. We need people to help us. So for example, today processing questions, I was reading them, and I don't know, it's kind of complicated. We don't know it yet. This is the first time, so any feedback, yeah, teacher assistant, it's a good. Thank you, Alan. So yeah, we will ask for your feedback, for your help. Just let us know, let's build all this together. All right, this is it. Keep posting your questions and keep working in the, yes, Juan, you guys can, of course, join to the Monday one again if you want. Like, keep it coming also in the Slack channel. We can form a study group there. And to be honest, I got a couple of interesting questions that I didn't even know the answers to, so we're all learning together here. So thank you very much. Thank you for the brave guys we have here now, if you still here, Alex and Colin. So first two panelists. Thank you for joining and being helpful and good people in general. All right, see you all on Friday,
Thanks,
Monday,
guys.
whatever. Have a great night. Thank you very much.
Yeah.